Hello everyone. In this video, we are gonna start a new series in which I will teach you about machine learning from the beginning. With the very fundamental concept, I will start, and then we will go to deep dive into this field using some examples in future videos. So it's a very new beginning, new journey. I hope you will like it. So no further ado, let's start with the first lecture, which is introduction part of machine learning. So in this video, we will learn about the basic fundamentals of machine learning. Why do we use machine learning? Their real world applications, or you can say examples. Then types of machine learning, main challenges while you are doing machine learning. What are the different challenges you will face? And last but not the least, testing and validation. Okay, so let's go to the introduction part. So the definition they have given in the book, which is goes like machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. So what does it even mean? Let me go to the whiteboard. So in this scenario, why do you even want to say that basically, let's say you are solving one problem in your computer. So generally, what is the traditional approach? Traditional approach. It will be like that there is a problem statement they have given to you. Now afterwards, you build your logic and you got the output. That's how it goes. While in the case of machine learning, we have a problem statement for sure. But in this case, we are not implementing our own logic. So what happened? Basically, we are feeding this data. We are feeding the data here, and you can say while external force means implementing stats or models, machine learning models, you can say you are getting basically you are training your data on this pattern. So what happened? This, let's say you are solving a problem here. Example like yeah, spam email is the very famous example. So what happened in the spam email? You have given the data that whenever there is a some spam email, I can give you example. Let's say very flashy in nature. For example, in which they have subject line free, 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 like this. They have given in the subject line. So in the traditional approach, what you can do, you can put this statement of this free, free, free whenever there's data can read that whenever this program will run, they will find out that is there any subject line which have this type of text there. If yes, then they definitely go to the this email and mark as the spam. Okay, that's how based on the traditional approach you need to find the pattern on your own, or you have the some fixed rules behind the logic. Now in ML approach, what we have given this basically we are giving the data on the basis of some targets and inputs. So input have been given in mails. So we are giving the data in this form that let's say this mail A is spam or not spam. So we are saying that mail A is not spam, not spam. Mail B is spam, and so on and so on. So we have given so many examples in the form of rows. in this data, we are feeding this data here. So automatically when they are looking for some pattern behind this spam and not spamming criteria, and in the end we will get the output based on the ML, and this output we generally call it prediction value. Prediction, in general term we call it prediction. So problem statement we have given, we are feeding the data based on some logics we have integrated here, and in the end we got the predicted value for the new test cases. So we can see the difference that in this scenario we are giving the logic here, or we are implementing on our own logic here, but there is something machine will learn here automatically through the data we have fed here. So this is called completely machine learning, in which machine will do automatically their own analysis, will try to find out the pattern, and in the end they have to give the output based on the pattern they have find out. In very simple language I have explained you machine learning. Now in the same scenario, machine learning can be categorized into you can say different types. We can see in the further slides. Let me go to the presentation. Okay, so generally we can call it that it's a shift in programming. Okay, we can call it shift in programming. Instead of explicitly writing rules and instructions, we are computer learn pattern from the data. Now, for example, rather than writing complex rules to identify spam email, we saw the system thousand example of spam and legitimate emails, allowing to discover the distinguished pattern itself. So this word is very, you can say, important here, itself. So when machine will do automatically based on data, this is called machine learning. This fundamental changes how we approach problem solving with computers. Okay, so now why we use machine learning, I have explained you that in the traditional approach, you have the problem, we write our own rules, then we evaluate. If it is fine, then we launch. If it is giving some sort of problem in the output, then we again reanalyze the problem and we do some changes there again, and then we again rerun the program. But here we have the problem, we train our model, machine learning model, we have feed the data here, then we evaluate and then we launch if it is fine. And what does it mean by fine? Means in terms of different metrics is already there. You can call it accuracy or score. Okay, based on the different problem you are solving. If it is surpassing your threshold, we will launch it in the production. Otherwise, we do the changes again and again. And these changes will based out of different data we are feeding also, and the different machine learning model we have to integrate here. So it depends on the problem statement we have to use. Now examples, these are the real world examples that we can analyze image of the products on a production line to automatically classify them. You can see one person is checking the quality check, doing the quality check, while in this is what AI is doing automatically. So you can say some human error we can neglect here, or we can also reduce the chances of, you can say, some manual interference. So this is very you can say major use case, detecting tumors in brain scans based on the image data we are feeding, and we can detect that this tumor is highly, you can say, dangerous or not. Automatically classifying new articles, automatically flagging offensive comments on discussion forums. These all are applications of NLP, which will be seen in the further videos. And again, this is also an NLP problem. So you can see we have three documents we can summarize into one document. It's application of NLP, creating a chatbot, generative AI, we can see. Now let's see the types of machine learning. So machine learning can be done in various ways. First one is supervised learning. The model learns from labeled training data. So the first example which I have given you is was the part of the supervised learning. Let's say this is male and this is target. So label data means that this male A is spam or not. If I'm saying 0 means not spam and male B is 1. So I'm giving the label data that this AB is the male and 01 is target. We know that this is what I need to predict. I know the prediction which I need to make. I need to make the prediction for the C, which is a new entry. I need to check whether it should be 0 or 1 based on the data which I have fed till now. And obviously this data will be in huge in number, not 2 and 3. And what is unsupervised? The difference between supervised and unsupervised will be that I don't know the target here. Automatically through the data, based on the data I have feed here, let's say ABC I have feed, they will categorize based on the, you can say, uh, different pattern they have, which we can't see, which we can't see, but the program have find out in such manner that they can group in some fixed rules. I'm telling you for through examples. Let's say A is this, B and C. Okay, and this is my place. Okay, or you can say customer. Okay, customer and customer, and this is demography data. So it's from US, UK, US. So I have feed them this data. So automatically, obviously they will clustering, or you can say grouping this A and C in one cluster, and B will be the different one. So if I can see this data in this form, so A will be here, B will be here, and C will be far away. If I'm plotting this data here based on this information. So this is what unsupervised learning. They will try to find out the pattern based on the data we have fed, but we are not providing any type of target here. So this is what they have already have a capability that they can analyze here. Just like customer segmentation, where system groups customer based on purchasing behavior, age, and location. So in this example, I have took this example of for demography. We can add more and more fields here, and through on that information, they will try to find these patterns between these customers. So this is what unsupervised learning. And semi-supervised means we are using both information. Let's say this photo organization software that learns from small set of manually labeled photos. That is beach and mountain. Okay. So in this information, we are using this supervised also and unsupervised also. And reinforcement learning means that there is a agent. Let's leave this example of agent. Let me pick something that makes sense here. Yeah, you know about chatbots, right? So chatbots, when we give some query here and ask some questions, they give answer, okay, based on this query. Sometimes they give right, sometimes they give wrong answer. So they are giving us option that we can categorize this, or we can give some feedbacks based out of this answer. When we say negative means this is not a good answer which I was expecting, or it is not a correct answer, then we can thumbs down. Okay, and this thumbs down means that they will get the penalty here. So automatically they will try to find the correct answer. So in this scenario, so whenever this we are giving this type of a reward system here, so they will try to learn from it. And you can consider this is like this. When a model is running like this, when we are giving negative, again this will rearrange this problem, reanalyze everything, and this model will learn through these mistakes and try to shift towards the reward system, means the positive side of it. Let's say whenever you're giving this correct answer out of it, and we are saying this answer is correct, It will more align to the correct side, and in the future case scenarios when the same person will ask the same answer, it will try to align with the you can say more correct side. In this scenario, 5 online learning means data will not go to directly in a one single batch, and it will go like a incremental basis. So generally we are using this online learning whenever there is a high chance that data will change with the time, or our model will not work in the future scenarios. So this online learning will work. We know that stock markets are volatile in nature, so every information which we are gathering today will not, you can say, that doesn't mean that this is it and we don't require the future data for the future prediction. No, nothing like that, because there are so many things in the stock market which based out of news also, and some crashes and wars. So this is something which always and always require, you can say, monitoring, and without continuous monitoring it's not possible to get a good model, right? And we need to consider that these models will take more and more time to train. So this is it. That doesn't mean that we are not learn about more and more types of machine learning models in the future. This is just a summarized view. There's also one type which is known self-learning models. Okay, self-supervised, I think. So it's just a thing that we are giving a name, but that the main context, or main, you can say, is conclusion of this slide is that we need to know about that what is this machine learning models can do, and are they are capable of doing what. Now the challenges we generally face and during the machine learning modeling is that sometimes we don't have the sufficient quantity of training data. What does it mean with training? So we have a training, we have a data, and we want to predict for the new entries. This new entries we generally call it, you can say, new instance also. Okay, so we have feed this data in our system, training data. Okay, so if this is only 2 and 3 rows, this will not learn anything. That doesn't make any sense also. So insufficient quantity of training data is the one challenge which generally machine learning models face, and it's a topmost challenge. Okay, poor quality of training data also means that we have a very much and data is very much noisy or imbalance. Imbalance means that let's say we are doing some demographic analysis, and we have only US means 10,000. Among 10,000 rows, we have 9,800 for US data and 200 for the UK data. So that doesn't mean that we can train this model on the UK data and it will give the false results for any UK customer for sure, because we have not even trained the enough data for the UK analysis. And overfitting and underfitting. Overfitting means that our model is performing very well in the training data, but whenever there are high chances that we want to know about the new entities, it is giving the false results. This is considered overfitting. And underfitting is like we are not even getting the good accuracy in the training itself. So there is a chance in this is underfitting, and it is something that our model is not able to learn the patterns from the data and can't even capture the correct one. This is what I have wrote here. Just like example, house price model care that memorize training data prices but fails to generalize to new properties. This is because our model is overfit. This can be solved through the more data when we feed more data, and we can implement a regularization. It's a future term which I will tell you. Feature selection and engineering. We should know about the which are what are the different features which really matters for predicting the new instance. Okay. Then resource constraints. It will require you high computational memories. So we don't have that. and we can do it on the cloud itself. That's not a big deal nowadays. Model interpretability. So complex models can be black books. What does it even mean? That just like you can say deep learning models, it's or neural networks. So there are so many weights concepts here, and we can't even understand that our model, which is predicting these values for new entry, we don't know how is it even calculating, how is it even means what are the formulas. We know the formulas, but we can't even analyze because there are so many parameters means there are so many variables. I mean in millions sometimes. If you are doing the good neural network analysis, it will take generally millions. And if you are gonna do manually these things to find out these million variables and find out the which one is very very important, we can't do it. So it's really difficult to do the model interpretation here. Okay, but and also we don't know the why reason also. Sometimes let's say our model is giving any application which I have wrote here that bank has rejected, or in the machine learning model for bank has rejected. We don't know the why because this is a black box for us. Now, production deployment challenges that model that work in development, and development may fail in production environment, but handle real world traffic spikes or data drift. Data drift means data will change with the future. It will change with future. We don't know that traffic spikes whenever there are high chances that it's a newer time. So there will be a traffic jam everywhere. So we did development of based on the 2 3 months data, but now there are spike in the traffic, and now our model is gonna fail because this didn't consider this scenario, and now we are if we are giving the new instance based on the analysis, then it will gonna fail. So these are something we need to consider before even starting the machine learning modeling. Now testing validation is the important thing here. A train test split. So what does it even mean? So let's say this is complete data of 100% which we have feed. Among this 100%, 60% which we generally gave it for the training data set. The, then we gives rest 10 to 20 for the validation and rest for the test. So there are different hierarchy we follow. First we train with the training data, then we train this data. If we are getting the good accuracy, then we run the same thing for the validation. Again, if it is showing the same thing, means there are very less error, then we surpass this thing for the test test data, and then we run our some metrics here, and we calculate generalization error. If it is less than threshold, we consider, then this model is good to go. Okay, but there are one thing we can do also here, which is known as hyperparameter tuning, which is a concept which I am gonna tell you while I'm doing this thing. Okay, right now it doesn't make any sense now. Cross validation is means, let's say we want to find out what are the different parameters which is good for the model. Okay, so we run this model for different subsets. Not only for this complete batch, we make some five. Let's say if I'm giving k is equal to 5, so it will break this training data in 5 points. Then this will run, this will run, this will run. Okay, and we will test this thing subset, and each subset serves as test sense, and once while others are used for training. Okay, help assess models consistency across different data splits. Example in five, which I have told you, this is fivefold. A model is trained and tested 5 times, each time using a different 20% data. Every time we are gonna use different types of data, and wherever we got the good accuracy, we use those parameters for the main model. Now, performance metrics is something which we are used to analyze our or evaluate our model. Classification and regression. Classification means that there is categorical data we need to see. The spam email is a type of classification, means class A or class B. It's a classification. So in this scenario, we generally consider accuracy, precision, recall, okay, F1 score. These are some metrics which I'm gonna tell you while I'm doing the coding part. ROC curves and AOC. Regression is something we for the continuous data. Let's say this is a pricing, house pricing you need to find out. Okay, so it will be in rupees or dollars, you can call it. So this will be analyzed through the mean square error, RMS, MAE, right? So these are the different evaluations just to analyze that our model is working fine or not. Validation techniques, hold out validation, simple train test split. Okay, time series validation, stratified sampling. These are the part of validation techniques, just this. And it will make more sense while I'm doing it. Common validation pitfalls, data leakage, test data inventory influence training, selection bias. So when I am doing this type of analysis and when the feeding this data into the model, it's generally matter that what are we are selecting, right, for the training data. Sometimes I have given you example of this here, this one. This is selection bias example. Overfitting in validation set, too many hyperparameter adjustment we are gonna do, then it will make that it will capture, you can say, each and every point pattern, which we don't want. We want to create a generalized model, right? So this is it. We have studied testing and validation, main challenges, types of machine learning, examples, why we use machine learning, and machine learning concept and fundamental introduction. In the next video, we are going to learn about the classification problems, and I think we can go to the coding part, and we will try to solve as many as real world problems. So that's it. Thank you.